Hello everyone, welcome back to the lab. Well, while I'm waiting for several parts that should allow me to close some old projects, I have received these two instruments that I have purchased separately. They have been very good deal, and I hope I can save them. They were ready for scrap. Unfortunately, during the shipment, the instrument down here has been damaged and broken in pieces, and that is a real pity. By the way, sometimes both dealer and forwarders doesn't do the right job. So what we have here, we have an HP5345A sweep oscillator together with the plug-in 8621, which should be capable to give an output of 1.7 to 6.5 gigahertz, but I'm not sure on that. And here we have a frequency counter, which is an 5345A or B, not sure yet. The lettering here is completely faded out, and it comes with the plug-in, which is a frequency inverter. The model is 5255A, which is capable to down convert frequencies from 3 to 12.4 gigahertz in order to be read by the frequency counter itself. Well, as you can see, they are pretty damaged and in a very bad shape. So the plan is try to save them. We will care about the aesthetic just in case they are not really for scrap. Hopefully not. Where start? Well, this instrument I know a little bit less, so I would like to skip to a future video. In this video, I want to try to start to take care of this and see if we can in some way bring back it to life. Both power switch are operating. This is pretty much sticky. This is pressed onto the front panel. So here we should have also other push buttons, I believe. So it seems that the basic function, mechanical function here are correct. Here we have some missing knob. It's broken here. Here there is just a partial amount of it, but should be good to at least attempt to test. The shaft here is pretty much bent. I will try to straighten it up. So, but enough talking. Let's jump onto this one. Well, as a first step, I will remove the plug-in and see if it is possible to remove it. Yes, it seems so. And I already have spotted a wire here which says aux in, so auxiliary input, which I'm not seeing. Aux in, it's like it's this one. So yes, indeed, it's connected to the BNC. So that must be figured out. It's missing one screw here, another one here, and most likely all of those are pretty much damaged. So somebody for sure has been here before. Oh, and to the bottom, a lot of screw missing. Hopefully there will not be missing parts. And here we have the tuning cavity, some dust and lint. Okay, so let's jump onto the instrument itself. Well, I've just realized that here we have a 10590A plug-in adapter, which is pretty cool. And this in itself, it's another, oh, it's so long, I have to slide down. In itself, it's another piece of instrument. And I think this should allow to plug all the 5245 Nixie frequency counter onto this. That is pretty cool. Look at the damage here, very bent. So let's go ahead with the removal of parts. This is the back of the instrument. You don't see any label which give us the model number and options. But looking at this, it seems that it has the organized reference oscillator. So let's open the top and see. Screws are removed. I'm going to see together with you. Might be that missing parts, anything can be possible. Oh yes, there is the organized crystal oscillator over there, 10544. It's missing one board, which, if I'm not mistaken, should be option, the interface option with HPAB or other kind of digital connections, but shouldn't be a problem for test the instrument. So it seems that everything is there here and untouched, hopefully. Here it's pretty much screwed up, and I think there might be a problem on the onto the reference oscillator. Don't know, but that's not normal. It seems that somebody has struggled keeping it onto the right frequency. Well, as the condition of this instrument are quite scaring, I want to remove also the bottom cover and see if there is I heard something rattling inside, so not sure if there is something that is loose and flying around here, making some shorts maybe. Oh, I'm just seeing now, this is really bent. This is really bent. There are test point. Somebody has fighted with this instrument quite a lot. Well, I've just been able to fit a screwdriver here, and this fell out, which I believe it's a screw coming from here. Yeah, that's it. Okay, let's see down here. Well, actually not too bad. It's not too bad. As I was still hearing something that was loose inside, I shake a bit the instrument, and these two pieces fell out, washer and a red plastic things that seems to belong to the display unit. So the plan here is to remove all the board, which I presume they will be very sticky, and I will not use that for sure. We broke, and I wonder. Okay, first one came out. Two adjustments. Nothing is on, but seems okay. Let's see if I can remove this. Yes, I can. Again, nothing about logic things. Don't know if there are any only TTL or CMOS. Then we have this again, full logic. Probably it's the counting section, but we'll be more sure later on. Okay, that looks like more maybe some counters, or maybe RAM and some logic. Logic and discrete transistor, don't know what they do. And here seems that looks like maybe digital to analog conversion. Don't know, but look how beautiful are those ICs, all gold plated. That is magic. These instruments really are superb. And this instrument has been released in the 70s. So it might, I don't know yet the year of the manufacturing, but it seems, looking onto this board, by the way, it seems 72, but not sure. Let's see on the other, 77. Yeah, 77. Well, I still have 3 boards, I think, here. These boards, I think these are, oh, look at that. We have this flying around, and that was not good, as these capacitors. Yeah. Well, this seems a regulator board, and this seems to belong here. Okay, you have another board with nasty corrosion signs over here. For sure, this instrument will require a lot of work and checks before the first power on. I'm seeing very bad corrosion signs over there. Let me grab the wrench for here. I'm removing these plugs, and I'm seeing here a lot of scratches onto this sort of nut, which again, somebody has struggled a lot here. The process of dismantling is continuing, and this is the crystal oscillator, which is pretty bad damage here. Removing the front panel, there are 4 screws placed at an angle, and there is a socket over there, and another one over here. And here we have another broken part, very nasty shipment. Well, to have the complete access to the main board, which it's quite in need of cleaning, and hopefully the repair required is minimal. I have found that this connector is broken, but the bit is here, so I will try to glue it back in place. So to have a complete access, I had to desolder all the wirings of the transformer, as well as of this front connector. Well, the cleaning of the main board has given a good result, and quite happy with that. Well, with the main board cured, I think it's now time to take care of this front panel and do the best that I can. It's in rough shape, it's quite dirty, and so contents need to be inspected, and I want to see what's inside this cage. Well, the dismantle came up pretty fine, and I think I will be able to give it a good polish. So this part of the board came up pretty easily, but this, it's very sticky. I don't know if there is something that is gluing onto the front panel. I can't see down there. Oh, that's what we have is a foam which was almost bonded to the PCB, and the condition here, it's quite alarming, but hopefully we can fix everything. And yes, I found a place where the red transparent bit of plastic I found before belongs to. This is the display as it came out from the front panel. It's quite difficult to remove the glass cover here, as it is already cracked, but this bent part of aluminum, it's preventing the plastic to come out, as there is this tab which also is quite precise in its groove, so I'm not sure how to go ahead. So hopefully I've been able to gently push behind here, and it came out. It's already cracked, the lettering is completely faded out, but it's there, so it is what it is. And this is the internal PCB. I think this is the LED driver, as we have these large transistors. Probably there is also, don't know, a sort of matrix decoder for the 7 segment, and yeah, resistor pack and some glue logic all around, and another power transistor over here, probably to manage the current. Here we have also, I think, few lamps which I'm going to test before reassembly. And yes, it seems everything dirt, but not damaged, at least. And those are the lamps arrays for the indications here, and the relevant drivers, I believe. And there we have it. Everything is assembled. The cleaning is starting. Well, I'm in the process of restoring the display, and I found one broken pin here that luckily I found a bit here, and there is another one over there which is stuck inside the socket. So hopefully I will be able to remove it and maybe solder back onto the display, and check all the other legs for weakness, and try to cure those. Well, I've been able to remove the stuck leg, but this 7 segment IC, it's pretty bad. There are already 3 broken legs, but there is another one here which is almost done. Very weak, so let's hope to save it. So I've inspected all the 7 segment displays, and 5 of those have at least one weak leg. So let's figure out how to solve it. All the displays are repaired, not the cleanest job in the world, but this is the worst one, and still need to clean a little bit better, but seems fine. So only when we will test on the hopefully working instrument. We will see if they are okay. The display is fully reassembled. While I was here, I have checked all the lamps. 3 of those were broken open, and it was Hertz, second, and arm lamp that were faulty. So let's see if I have a mustache. Luckily I have the drop-in replacement, so I can now reassemble all the light guides and the lettering, so can go ahead with the restoration of the rest of the front panel. This part of the display is ready. To the next one. Well, the display section is finished, reassembled and polished as best as we can, as these scratches here are pretty deep. The indentation here I've been able to straighten up a bit. I have repaired the broken one. So let's jump onto the PCBs. Well, I am almost done also with this section, and I have noted that this wire was flying to the breeze, as well as this red one, which I have already soldered back in place. There was so weak. This wire is going in this tiny hole. Can you see there? And it was already loose. Let me take something to point onto this tab. There is a tiny hole. This hole is for this wire. It's a ground wire. It was almost unsoldered or very weak. Okay, this section of the front panel is reassembled. All the switches are cleaned, lubricated. So it seems I have straightened also this shaft. So let's hope for the best. To continue the restoration of the front panel, I had to remove all the switches. They are sliding switches, as they were completely locked, and there is a lot of dust down there, so this must be washed thoroughly. This frequency counter can count by itself up to 500 megahertz, so I think it's important that must be very clean. Well, the board is cleaned as best as we can. All the contacts are cleaned and the plastic has been rejuvenated. So it's time for reassembly. And that's the front panel cleaned, reassembled. This is the best I can achieve with what we have, but seems a good step ahead. So I have swapped those two knobs because it's more convenient to have in that place. So let's go to the next step, which is the transformer and wiring harness, together the fan, and start the instrument reassembly. That's the fan completely disassembled, very serviceable. There is an oil reservoir with 2 felts, so it's a quite nice design to work for a long time. Bench test of the fan, perfect. So the wiring harness is cleaned, fan and shroud is reassembled and cleaned, as well as the board shield. So I think we can now at least restart the reassembly of the main board with the main transformer and this part and the back panel. Well, I made good progress with the reassembly, and I've just realized that I didn't check the main power transformer for continuity, and luckily it's okay. So I'm go ahead with the test of the fan, at least without any load, applying the front panel power switch. As you can see, the main transformer is always plugged in, which I really don't like it, but it is what it is. So the fan will be switched on only when the standby on switch is operated into the front panel. So I will plug with dim bulb and variac, so being the safety side. So there we go. We are at the beginning of the test. I have my dim bulb. It's already connected to the variac, and the power switch is in the off position. So I'm going to rise up the voltage. We should see a bit of light onto the dim bulb. At the moment, nothing. I'm already at 160 volt, and I think there is nothing that is happening. So let's switch on, try the same. And yeah, the fan is starting to spin. The dim bulb is lighting up. 160 volt again. Okay. So it seems that the power transformer is not draining any current in the without any load. I've raised the voltage to 180 volt, and the fan is starting to spin faster with a good airflow. 200 volt, everything good so far. 220 volt, still through the dim bulb. Everything fine. Fan is pretty silent. I'm going to bypass the dim bulb. That's the full voltage onto the fan. Looks fine to me. So we can go ahead with the regulator boards and see how they are. These are the two regulator boards. I already have checked all the capacitors, and they measured perfectly fine as brand new, and it's quite impressive. Despite they look pretty similar, this is a linear regulator board, and this is a switch mode regulator board. They have this hybrid technology put it in the same instrument, which is quite quite interesting. So I think I will reassembly all the capacitor here. I will not apply the zip ties that were on. This were onto the capacitors. I have removed it for lift them and checked them. It seems that somebody has already applied fresh thermal paste, so I will not need to do that job. So I will start with the linear regulator board and see the voltages that are coming out. There are additional tantalum capacitor over here, which rarely they fails. So I will leave them alone, and I will care of those only if I will find some problem. So let's reassemble the capacitor on this, apply onto the instrument, and check some voltages. Oh well, I totally forgotten that on this board we had that corrosion signs, which actually it seems that something has some kind of liquid has dripped in, or maybe the overheating thermal paste over here, not sure. So need to clean the board thoroughly and reassembly. No more corrosion to the board, time to test. Okay, the setup is ready. This regulator board gives multiple voltages. We have plus 22 unregulated, plus 12 regulated, plus 11 regulated, plus 15 regulated, minus 15 and plus 20 regulated voltages. So I'm going to check those regulated voltages, as the unregulated is coming from the bridge rectifier, which generates also the plus and minus 15. I already have connected two voltmeter. One is on the plus 20, the other one is on plus 12, and then I will move on to the other while I will raise up the voltage. All right, variac is at 0 volt, dim bulb is enabled, power on switch onto the on position, and I'm started to rising up, and we already see some voltages. Oh, by the way, the resistors that are soldered onto the main board are meant to load very lightly the voltages, so shouldn't be hurting the power supply, but the same we will have some load, and the regulator circuit can regulate. So I will keep on rising up, and as you can see, we have this voltage which is rising. This is almost stable. Let's continue. Resistors are cold. So I will keep at these voltages. I'll be back. Monitoring the 11 voltages is not giving crazy voltage, so doesn't mean that works, but seems acceptable. Oh, no board on the instrument, by the way, only the power supply. This one, the A7 linear regulator power supply. Let's check again the plus 20, which is still onto the good position. This is minus 15. Let me switch this. Go back onto plus 15. Yeah, it's a bit low. Increasing more. We are good here, we are low there. And I think we are at 210 volts. Let's raise up a bit more. Yeah, we are approaching the minus 15, which actually is reversed here. Yeah. Well, it's a bit of time. It looks fine to me. Let's check the other voltages. Plus 20, still a bit low, but still with dim bulb and not yet at very full voltage. Starting to become bright, and plus plus 20 seems not to regulate perfectly. Minus 15 and plus 15 are pretty stable. Let's check the other voltages. Plus 11 is a bit low. And plus 12 it's almost there. We are without any load, so I think we can check directly to the line. Well, I am onto the line directly through the bulb, but the plus 12, which are now again reversed, seems that is always on. So let's power up. Yeah, minus 15, it's going fine. Let's check for plus 11. It's a bit low. It's a bit low. Let's try to bypass the bulb. Yeah, it needs more juice, but seems fine to me. So we can go ahead with the other power supply board. Well, I actually moved my meter onto the plus 20 and should be regulated, and it's not. It's pretty high. So I think here we have something to check. It might be that we have an open or damaged Zener diode or IC. So the way that it works, it's using a voltage regulator, a 7415 plus 5.1. We should have 20.1 volt around, but we are having 27. Now, since the incoming voltage is 28 volts over here, so I'm afraid that we have a shorted regulator, which is over here. But with these two different extensions, I have removed the key onto the socket there. I can make a dynamic test. The bulb is attached, monitoring the plus 20, and I will use this to measure onto the bird. Let's power on, and it's rising up to 18 volt. But if let's check for short. If I bypass the bulb, we are going to 27. So let's check onto the diode. And I have my 5 volt. So I'm afraid that our regulator is not regulating. Okay, let's see if I can check voltages across the regulator. 28 volt is the incoming voltage. Not easy to measure. I should measure here. And we have 27. And this is plus 5. So that might be correct. So I should measure from here to here. And it's 22 volts, and it's not correct, so the regulator is faulty. Well, unfortunately, it's faulty. I likely have a replacement. Don't know what kind of damage in the instrument can can have caused this shorted regulator. So I will check if I will find a sort of block diagram and see what plus 20 volts it's supplying. Okay, the regulator is replaced, so we can now plug back the power supply. Okay, monitoring again the plus 20 volt over there. Let's power it up, and clearly we still need to raise up voltage, but I think it's behaving the same. Not really. We are good now. We are 19.7. Yeah, this IC was faulty, so hopefully the extent of damage in the instrument is not too bad. Well, unfortunately, looking at the manual, I can't figure out what the plus 20 volt is feeding quickly. So I went ahead and I tested all the capacitors also in the switching regulator board, and I will go to test also this. I will worry about the damages later on. Hopefully it's salvageable. There are some parts which are unobtainable for sure, but we will worry on that later on. A6 switching regulator assembly. It's providing different voltages. Specifically, we have plus 5, minus 5.2, which is both of those are regulated. And then we have some unregulated voltages as plus 8, plus 5, which are meant to be used onto display and other purposes. But I'm not too worried about that. So I will give a very light load onto the plus and minus 5 volt rails and see if we can bring back to life also this part of the power supply. So the concept will be the same, loading the voltages. I need to load also the plus 5 display, as actually it is fed through this regulator, which I believe is 7805, but not sure about that. So what I've done, I've applied 3 resistors, 1, 2, and 3. I'm monitoring the plus and minus 5 volt, 8 volt, the 5 volt for the display I will check later on. So I will apply power, but not through the variac, as this should be a switching power supply. My schematic is not really complete, but usually they don't like slow voltages, so I'm going through the dim bulb, but not with variac. Okay, so I'm going to apply the rail, the power supply. Dim bulb is barely glowing, and I already see some voltages over there. Not sure if it's correct. So let's try that. Oh, look at that. Spot on. That is beautiful. That's perfect. Okay, that is a good step ahead. I will leave the instrument to sit at this lower voltage through the bulb and let the power supply work and warm up and see if nothing happened. Oh, by the way, we may want to check the plus 5 volt for the display, which are also spot on. Very nice. So let's continue with the testing. Well, it's almost 5 minutes that it's running smoothly. So I want to bypass the dim bulb and see what's happened. 3, 2, 1. So voltages remain where they was. So seems fine to me. Well, it's almost 20 minutes that it's running, and it hasn't highlighted any problem so far. So I think it's safe enough to mount the front display and see if we have some life signs and all digits are lighting up. I don't know if it will happen without any other bird, but I want to try that. Okay, the front panel is fitted in place. Let's try what it does. Dim bulb is enabled. Okay, we had some voltage signs here, but it has dropped my 5 volt over there. I'm afraid something happened there. Well, I tried again, and it seems that we don't have enough juice. Yes, we now have some life sign here. We have seen a bit of life also here, but we need all the other bird. But seems good so far. I was looking through the boards and I found this, and it seems that we have a faulty IC. That is a bummer. By the way, hopefully it's only on one channel. So and I have seen also quite a lot of reworking here onto the IC's shield, and don't know what to do. By the way, I will reassembly everything and test, as I think it's the only way to be sure that whoever has done this troubleshooting, it was correct. So I quickly place all the board in. I'm too much curious to see if we can have some life sign from this instrument. I already have plugged it to the power supply. I don't think it will go with through the dim bulb. It's too small. 3, 2, 1. Okay, but we have seen some life sign from the display. So let's go for broke and bypass the dim bulb. 3, 2, 1. Oh, look at that. Look at that. Beautiful. Okay. Okay. Let's see from here. I think there is something wrong, as I do not see any dot moving. reset, it's working, and all the display are working. That is very nice. A, B. Oh, okay, this is a period and it's switching. And if I go to check, we have no count, nothing at all. And I think this means overflow. Let's try to restart. Okay, but this implies that a lot of things are running and it's already a good step ahead. So, but for sure we have no live sign onto the counting section. Okay, I think we need to troubleshoot deeply the instrument, and went out on live. Oh, the gate, it's starting to blink. I think there is something funky going on. Okay. Well, it seems that we have some problem in the logic, especially, yeah, here on those long. Okay, because those are seconds. Yeah, so gate, it's running now. And this would mean milliseconds, milliamperes, sorry. Yeah, there is something wrong also onto the range, I think. Yeah, there is something funky here. Okay, by the way, we have achieved a very nice step ahead. We have live sign, so it's time to troubleshoot. Well, as this video is already long and the troubleshooting will be pretty much involving, so I think it will need a specific video. Hopefully the next part will be enough to fix the problems. So I hope you have enjoyed this, at least bring back to life of this beauty, and I'll be back soon. Thank you very much for watching.